Hi, my name is Owen Edelstein,
And my name is Lindsay Fabricant.
and our study is the effect of microplastics on the speed and mortality rate of Daphnia magna.
Microplastics are degraded forms of plastic consumer products, and they are polluting ecosystems throughout the world. Recently, microplastics have been found in human feces, so researchers are observing the effect microplastics may have on the health of many organisms, starting at the bottom of the food chain with species such as Daphnia magna. In addition, microplastics have also been found to accumulate in the stomach and intestines of many marine organisms. Therefore, we ask the following questions. How does microplastic consumption affect the speed and mortality rate of Daphnia magna? And what is the difference between the effects of polyethylene and polystyrene microplastics on Daphnia magna?
There are two common polymers of plastics, polystyrene and polyethylene. Polyethylene is an organic compound that consists of ethylene monomers bonded together and makes up a majority of plastic consumer products, such as plastic water bottles, plastic bags, and toys, while polystyrene makes up consumer products such as styrofoam. In addition, the main difference between polystyrene and polyethylene is that, as shown on the side, styrene has a pendant group of CH2CH instead of a hydrogen molecule in ethylene. Daphnia magna are a marine organism that are crustaceans and are also known as the water flea. According to previous research, Daphnia magna that consume polystyrene microplastics experience an abnormal increase in speed, body length, and reproduction rate. As well, polystyrene microplastic ingestion has been linked to an increase in body length and uptake of microplastic, although there was no toxic effect. On the other hand, Daphnia magna that ingested polyethylene microplastics at high concentrations became immobilized. However, there was no statistically significant effect on their mortality.
This led us to hypothesize that Daphnia magna that consume polystyrene microplastics will have a higher mortality rate than those that consume polyethylene microplastics and those that do not consume microplastics. We also hypothesized that Daphnia magna that consume polystyrene microplastics will have a greater speed than those that consume polyethylene microplastics and those that do not consume microplastics.
In our study, there are two dependent variables, speed and mortality rate, and the independent variable of type of microplastic, either polystyrene, polyethylene, or no microplastics, which was the control. Our study consisted of 7 30-milliliter jars that had 25 milliliters of pond water and 5 Daphnia magna in each. And each group was either fed 25 polyethylene microplastics and 1 milliliter of algae, 25 polystyrene microplastics and 1 milliliter algae, or just 1 milliliter of algae for the control. In addition, each container pond water was cleaned weekly to prevent sickness. As shown in Figure 1 was the overall setup of our study, and in Figure 2 is an example of a singular jar.
Below, we mapped out the steps to test for speed and mortality. To test for mortality, every other day, we recorded the number of Daphnia magna that were living. We recorded these results for 20 days. In addition, to test for speed, we ran a phototactic response test weekly. As seen in Figure 3, 1 Daphnia magna from each container was placed in a graduated cylinder filled with 25 milliliters of pond water. We held a flashlight above the graduated cylinder and recorded a video of the Daphnia magna swimming toward the light at the bottom of the graduated cylinder. Then we uploaded these videos onto ImageJ software and analyzed them to find the exact speed in centimeters per second.
After collecting our data, we ran a one-way ANOVA that showed there was no statistical significant effect of the type of microplastic on mortality rate, with a p-value of 0.564. The graph shows that the control group had the highest mortality rate percentage of 83.636%, followed by the polystyrene group with 81.818%, and lastly, the polyethylene group with 70.01%. We think these results most likely occurred because, according to Kiviori and Lads of 1996, temperature fluctuation can lead to an increase in mortality rate of Daphnia magna. And at the beginning of our study, we experienced a complication where a majority of the Daphnia magna in the control group died. And this could have possibly been caused by temperature fluctuation because we ran the study in our school where we could not regulate temperature.
We ran a one-way ANOVA for the phototactic response test. The results were not statistically significant with a p-value of 0.648. As seen in the graph, the Daphnia magna that consume polyethylene microplastics had the greatest speed, followed by those that consume polystyrene microplastics, and lastly, the control. The lack of statistical significance is most likely due to the limited sample size of Daphnia magna in the test, since we had experienced a high mortality rate at the beginning of this study.
When conducting the phototactic response, we found that the Daphnia magna in the experimental group experienced irregular circular swimming patterns when trying to swim towards the light. Meanwhile, the Daphnia magna in the control group did not experience this and swam down towards the light in a straight motion. We decided to record this swimming pattern in the Daphnia magna each time we ran the phototactic response, and a chi-square test showed statistically significant relationship between microplastic consumption and Daphnia magna irregular swimming patterns, with the polystyrene and polyethylene groups, all of them having this irregular swimming pattern and none in the control groups, with a p-value of less than 0.001.
On the left, there is a video recording of Daphnia magna in the control, and it can be seen that they swam downward. Meanwhile, Figure 8 shows Daphnia magna after consuming microplastics, and they are swimming in a circular pattern as they travel towards the bottom of the container. Graduated cylinder. This study demonstrated a circular swimming pattern exhibited by Daphnia magna resulting from ingestion of polystyrene and polyethylene microplastics. Prior research suggests that ingested toxins can lead to changes in swimming patterns of Daphnia magna. Noss et al. Observed that titanium dioxide nanoparticles led to changes in Daphnia magna swimming behavior. In addition, circular swimming patterns have been an observed change in Daphnia magna in a study by Dodson et al. In 1996 after they ingested pesticides as a toxin. Therefore, these studies suggest that microplastics may be a toxin to Daphnia magna. Furthermore, as suggested by Dodson et al., these circular swimming patterns may harm the Daphnia magna, as it quickly exhausts them and wastes resources while presenting them as a target to predators.
One significant limitation of our study was that we performed the study at our school. Because of this, we were unable to regulate temperature or record the results often. For example, mortality rate was only recorded every other day. So in the future, if we were to redo the study, we would likely have a greater sample size and better conditions to monitor the Daphnia magna. In the future, studies could be done to test the effect of microplastic consumption on other freshwater organisms, such as planaria, shrimp, or isopods. In addition, another type of microplastic polymer, such as polypropylene, could be tested to find if it affects the speed and mortality rate of Daphnia magna.
These results do not indicate any relationship between mortality and ingestion of microplastics, nor a relationship between speed and ingestion of microplastics. However, the results demonstrated that ingestion of microplastics have a statistically significant effect on the swimming patterns of Daphnia magna, since they exhibited an erratic circular swimming pattern. Prior research about the effect of toxins on changes in Daphnia magna swimming behavior suggests that ingestion of microplastics may be a toxin to species such as Daphnia magna. Thank you.